Now let's create the UDP server. A UDP server follows almost the same pattern as a UDP client, except that you usually receive before sending and don't choose an anonymous port to bind to. Unlike TCP, there's no separate datagram server socket class. We don't have to span a new socket and continue to listen for new connection requests. Let's begin by opening a datagram socket on a well-known port. I'm gonna do datagram socket. Let's say socket equals new datagram socket, and I'm gonna use port 9090. We add the byte arrays, and I'm gonna use a while loop to accept multiple clients. While true, this time we don't need to create a separate thread because we don't have a separate connection for each client. If multiple clients access this application, they will all send their packets into this single server socket. Remember from the UDP intro lesson, if multiple UDP packets arrive at a destination, all of them must wait in a queue before all their preceding packets are processed. I'm going to show you later in this lesson how the UDP server processes datagrams for multiple clients. Now I'm going to create a datagram packet into which to receive a request. I'm going to do datagram packet, let's say receive packet equals new datagram packet. You need to supply a byte array in which to store incoming data and the byte array length. Dot length. Then we receive the packet. I'm going to call the receive method. Socket.receive receive packet. Again, this call blocks indefinitely until a UDP packet arrives. Let's create a string from the received bytes. Equals new string receive packet dot get data, and print the string value. Now we want to create a response packet. I'm going to create a string variable string data equals hello client. And I'm going to convert the string to a byte array using the getBytes method and store the characters of our string in the byte array. Send data equals string data dot getBytes. I'm going to create a datagram packet. Send packet equals new datagram packet. Send data dot length. Specify the client IP address and the client port number, which is chosen by the client and is different from the server port number. Let's say client port. So we have to obtain the client IP address. We can obtain the client IP address using the datagram packet getAddress method. I'm gonna do inet address client IP address equals receive packet dot getAddress. This method extracts the IP address of the client from the datagram IP header. The IP header contains the sender IP address and the receiver IP address. We also need the client port number. Remember from the previous lesson that the client picked a random port and we want to know the port number to build the UDP header. The UDP header contains the receiver port value and the sender port value. For our UDP server, the sender port value is 9090 in the send packet datagram. I'm gonna call the datagram packet getPort method to obtain the client port. Int client port equals receive packet dot get port. Then all you have to do is to send the datagram using the send method. I'm gonna do socket dot send packet. Okay, now let's test the application. Start the server and then the client. And you can see that the client has received the server message, and also the server has received the client message. The message exchange was performed successfully. You can connect the client again, and we obtain the same result. Now I want you to show the UDP server behavior when multiple clients send datagrams to it. We have a server that is waiting for datagrams, and it prints the datagram data on the console, and two UDP clients that send a string message. I've used a loop to send the text message continuously. Client 1 sends client 1 text message, and client 2 sends client 2 text message. Unlike with TCP, you can first execute the client side and then the server side. This is because when you execute the client side, the client process does not attempt to initiate a connection with the server. So let's start client 1 and client 2. Now the clients are sending datagrams to the specified IP address in the datagram IP header. They don't need to connect to a server to send packets. The server is not started yet, so the datagrams arrive to the remote host and they are dropped because there is no service listening to the port specified in datagram. Now let's start the server. And we can see that the server accepts packets from both clients. This is different from a TCP server client application. For a TCP server, you have to create a separate thread for each client in order to process different clients' requests. The TCP servers can process different clients' requests independently.